Okay, now we're going to be learning about Charles' law and Amonton's law. Again, we're dealing with gases, and the gases, again, we're learning characteristics about gases so that we can describe them differently than liquids or solids. So first, let's look at Charles' law. Charles' law again, we're dealing with gases, and his law, you can read the book, but basically it says that if the pressure of a gas is constant, then its volume and temperature are directly proportional. In other words, V1 over T1 equals V2 over T2. So let's think about that. If we have a volume and we decide to increase the volume at a certain temperature, and we decide to increase that volume, what would happen with the temperature? This is very interesting because this is how we get things compressed, and we change the temperature of things, and we can actually start to heat and cool things. So it's a very interesting way to that we'll take a look at regarding ideal gases. And then the other law is called Amonton's law. And that law gives us an equation which is very similar, but it just deals with pressure. The pressure and temperature will change proportionately to each other. So let's think about this one. If we have a temperature and a pressure set on a certain volume, what will happen if we decide to increase the pressure? Will the temperature change? So those are questions that we're going to answer in our application problems on page 48. So let's take a look at page 48. The first problem is, if the volume of a gas quadruples, how does the absolute temperature change? That reminds me, one of the things that we need to do with these first laws is we have to use absolute temperature. That means we don't use Celsius and we don't use Fahrenheit. We have to use Kelvin. That's the only way that we can do these. So the question is, if the volume of a gas quadruples, how does the absolute temperature change? So like we did in our other problems, we write down what we were given, and this one is asking about volume and temperature. So we are going to use Charles' law because it's asking about volume and temperature. So let's start with what we're given. For this one, let's call V1, and the temperature would be just the same thing, T1. But then we change, for the second part of it, we change the volume to 4 times V1, because that's what it said. It said it quadruples. And when it quadruples, that means we have to multiply the initial volume by 4. And the question is, what would the final temperature be? Well, we just have to look at our equation and write that down. V1 over T1 equals V2 over T2. Let's put in what we have. Well, V1 is simply V1. T1 is simply T1. V2, though, that is actually going to be, so we have V1 over T1 equals 4V1 over T2. Well, let's solve this a little more. I don't know if you guys know how to do cross multiplication, but I like to just multiply this, switch this to this side and this to this side. Then we end up with an equation that says T2 equals T2 over T1 equals 4V1 over V1. So then you can divide those out, and then T1 you can cross multiply to get it over there, so you actually have T2 equals 4 times T1. So what we did was we said the volume is going to quadruple, and when we quadruple the volume, if we've kept the pressure the same, guess what? The temperature is going to go up quite a bit. Now let's think about that. This is called compression and decompression, and we actually use this when we're heating and cooling things. So if we keep the pressure the same in a system and we want to increase the temperature, the only thing we have to do is increase the volume. That was problem 1. Let's look at 2. If the absolute temperature of 1 liter of gas decreases by a factor of 2, what will be the new volume? Now this is a confusing problem for somebody that's in middle school, but let's try and figure it out. Let's say the absolute temperature of 1 liter of gas decreases by a factor of 2. So let's do our initial temperature. We don't know. Let's call it T1. Let's say, and then we also want to know what we will call the first volume, V1. Then they tell us that the second temperature will decrease by a factor of 2. Well, when they say by a factor of 2, they mean they divide it by 2. In other words, it's going to drop by half. So T1 over 2. That is the new value. That is to decrease by a factor of 2. What will be the new volume? V2 equals question mark. Well, let's look at our equation. Our equation again is Charles' law. V1 over T1 equals V2 over T2. So we're going to do V1 over T1 equals V2 over T2. So V1, we're going to leave it the same. T1, we're going to leave the same. And so we end up with V1 over T1 equals V2, which is what we don't know, over T2. Well, T2 has T1 divided by 2. Well, how do we solve this? Once again, we can multiply, cross multiply, and because we want to solve for V2, which is right here, all we have to do is cross multiply the T1 over 2, which is the same thing as saying I'm going to multiply the top by T1 over 2 on both sides. And if we do that, then T1 over 2 gets divided out there, the T1 gets divided out here, and we actually end up with V1 over 2 equals V2. So what happened when we decreased the temperature by half? Well, the second volume actually decreased by half. So they're proportional to each other. They're exactly proportional to each other. When you increase one, the other one's going to increase. When you decrease the other is going to decrease. What about problem 3? The temperature of a 3 liters of nitrogen gas is raised from 200 Kelvin to 300 Kelvin. What is the new volume of the gas? Well, let's look at this. We have the temperature, first temperature, and the volume. First temperature, they said, was 200 Kelvin. Okay, and the first volume was 3 liters. Their question is, what will be, the second temperature, they said, was 300 kelvins. And so they want to know what the second volume is. Well, we do our same equation, V1 over T1 equals V2 over T2. And so we have V1 of 3 liters. T1 is 3 liters. T1 is 200 Kelvin. Our second volume is just volume 2, and the temperature changed to 300 Kelvin. Well, let's solve for volume 2 by multiplying by 300 Kelvin on both sides. So we end up with V2 on its own. So now V2 equals 300 Kelvin times 3 liters divided by 200 Kelvin. Now you can use your calculator and just do 300 times 3. This ends up with being, the units will be liter, so you get 900 divided by 200 liters. That is problem 3. So those were all problems dealing with Charles' law. I think now we're going to change to Amonton's law, which is the same thing, but it's P1 over T1. So we'll do the problems very same way. So let's take a look at problem 4. So problem 4, it states, if the pressure of a gas doubles, how does the absolute temperature change? So this one again is a little confusing, but we're going to start with the first pressure, and we have the first temperature. The first pressure is just going to be P1. So we have the first pressure and the first temperature, and then they say that the second temperature is going to double. So it's going to be twice the amount of the first pressure. What happens to the second temperature? Well, let's look up at our law again. This one is Amonton's law, and it's P1 over T1 equals P2 over T2. So here we go with our law. P1 over T1 equals P2 over T2. And so P1 is going to remain the same. T1 is going to remain the same. Now the second pressure is going to be 2P1, and then they want to know what happens to the temperature. So what we're going to do to get the temperature on the right side is we're going to multiply by T2 and multiply by T2. That would divide out on that side. Then we're going to multiply by the inverse of these two. So T1 divided by P1, because that'll cancel this out. So we'll do T1 divided by P1. And what we end up with, when we cancel everything out, we get the second temperature equals 2 times the first temperature. So that is the same thing that we found when we were working with volumes. If we increase the pressure by twice the amount, then the temperature is going to increase by twice the amount. They're directly proportional, which is important for you to remember, is this whole idea of proportional, directly proportional. That means you change one in one direction, it'll change the other value in the same direction. Let's look at problem 5. If the absolute temperature of a gas with a pressure of 60 kilopascal decreases by a factor of 2, what will be the new pressure? So we have our P1, T1, and P2, T2. Those are, again, the values that we need to get. And it says the absolute temperature of a gas with a pressure of 60 kilopascals, so we have our 60 kilopascals, decreases by a factor of 2. And T1 is just going to stay at T1. They want to know what the new pressure is. The second temperature is actually going to be T1 divided by 2. That's what they mean by decreases by a factor of 2. So this is decrease by factor of 2. So we use our equation again, which is going to be P1 over T1 equals P2 over T2. Let's put in the values. P1 is 60 kilopascals. T1 is T1. P2 is what we're solving for. And then T2 is actually T1 divided by 2 because it decreased by a factor of 2. The temperature did. So let's go ahead and solve for P2. If we multiply by T1 over 2 here, that'll cancel this out. That means we'd multiply by T1 over 2 on this side as well. And what happens is this cancels out there. We're left with P2 equals 60 divided by 2 kilopascals, which means P2 equals 30 kilopascals. So that follows the same thing that happened before. This time we decreased the temperature by half. Well, that means the pressure has to drop by half, so they stay proportional. One more problem. 6. The air in a car's tire is at a pressure of 240 kilopascals. So I'm going to go ahead and write that down. The pressure is 240 kilopascals. And the temperature of 290 K. First temperature is 290 Kelvin. After the car is driven, the temperature of the air has risen to 320 Kelvin. What is the pressure of the air in the tire? This is really interesting because tires actually will have a problem. If the temperature increases, then the pressure has to increase too. I used volume there. I'm going to fix that. This is T2. So we have our equation, which is P1 over T1 equals P2 over T2. Again, we put in what we have, 240 kilopascals, divided by the first temperature, which would be 290 Kelvin, equals P2, divided by 320 Kelvin. Well, this is pretty simple to solve because we just multiply by 320 Kelvin on this side because that'll cancel that out, and 320 Kelvin on this side. This times this, divided by this. You can do your calculator and you will then come up with P2 equals 320 times 240 divided by 290, and this will all end up in pascals. You could use your calculator and solve for that value. Thanks.